This is SpaceTime, Series 28, Episode 124, for broadcast on the 15th of October 2025. Coming up on SpaceTime, high seas on the red planet Mars, a new analysis of the largest impact crater on the Moon, and a new mission by NASA to study the Milky Way Galaxy's interstellar medium. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has provided fresh geological evidence that the Martian Northern Hemisphere was once home to a vast ocean. Billions of years ago, water flowed across the Martian surface. There's plenty of evidence, both observational and geological, that the red planet once had rivers feeding into lakes and larger bodies of water. But did those rivers ever flow into an actual ocean? From orbit, there's clear evidence of what appear to be seashores, beaches, and river deltas flowing to what once was a huge Northern Hemisphere ocean. And now a new study, reported in the journal Geophysical Research Letters, has found more strong evidence in Martian geology that an ocean once existed in the planet's Northern Hemisphere. The study's lead author, Corey Hughes from the University of Arkansas, says there are no known life forms that can survive without liquid water. So, finding evidence that liquid water once existed on the red planet increases the possibility that life might also once have existed there. To better understand the geology of ancient rivers, Hughes and colleagues compared river rocks on Earth to rocks on Mars, including sandstone created by a river that once flowed across northwestern Arkansas some 300 million years ago. Hughes says you need to imagine a river with no human-built levees or dams to constrain its course. That river would shift constantly, like a ribbon snaking across the landscape. You see, rivers carry sediments, like silt, clay and rocks. These sediments eat away at one side, causing the river to curve in that direction, while at the same time depositing sand and fine dirt on the opposite side. The region that defines how far a river shifts from side to side over time is called a channel belt. Also, a river slows down as it approaches an ocean, which is a massive, comparatively still body of water. As a river's flow velocity decreases, it carries less sediment. So the solid matter starts to fall out of suspension, creating a river delta. And with less sediment to erode its banks, a river's movement from side to side also decreases. In other words, the channel belt narrows as the river approaches an ocean. This section where the river belt narrows and the river bed drops below sea level is called the backwater zone. The backwater zone of a river flowing into an ocean is long. In the case of the mighty Mississippi River, for example, the backwater zone begins near Baton Rouge. That's some 370 kilometres from the Gulf Coast. Looking at Mars from orbit, Hughes found geological evidence of ancient river backwater zones on the red planet. He's described it as a large-scale process, which is why he was able to see it so clearly from space. The presence of river deltas with long backwater zones provides strong evidence that large rivers once flowed on Mars and they emptied into an ocean before the surface of the red planet dried up billions of years ago. Hughes says these were very mature deltas, a strong point in favour of an ancient ocean or at least a very large sea. Now, as rivers flow, gravity pulls the coarsest grains to the bottom of the riverbed. If the river eventually dries up, that coarse sediment's buried. And over time, due to heat and pressure, that sediment eventually becomes sandstone. On Earth, shifting tectonic plates will push that rock to the surface, and then wind and rain will erode everything but the coarse channel bed itself, leaving behind a sort of ridge where the channel used to be. This process is known as topographic inversion. When a ridgetop is composed of sandstone that used to be at the bottom of a river, it's called an inverted channel belt or an inverted ridge. Now, Mars doesn't have tectonic plates like the Earth, so its inverted ridges were likely formed when finer deposits around the sandstone were eroded. And it's those inverted ridges on Mars which provide strong evidence of long-vanished rivers. As part of their research, Hughes and colleagues studied the Weddington Sandstone, a rock formation found across much of northwestern Arkansas. They realised the stone cliffs were all part of a branching network of inverted ridges formed by a 300-million-year-old river that once ran from modern-day Indiana through to the sea that covered central Arkansas. Scientists have known about the process of topographic inversion for 30 to 40 years now. But in northwestern Arkansas, the authors discovered the only known example of an inverted river delta on planet Earth. And that discovery has helped them identify oceans on Mars. This is SpaceTime. Still to come, a new analysis of the largest impact crater on the Moon, and a new mission to study the Milky Way Galaxy's interstellar medium. All that and more still to come on SpaceTime. A new analysis of the largest impact crater on the Moon may help astronomers solve some of the biggest long-standing mysteries of how Earth's only natural satellite came to be. The findings mean that when the Artemis crews land at the Moon's south pole in 2 years' time, they'll likely find themselves with a treasure trove of clues that could help scientists better understand how Earth's only natural satellite evolved. The Earth's moon was created some 4.5 billion years ago, when a Mars-sized planet slammed into the early proto-Earth, melting both bodies into a magma ocean, which eventually differentiated and solidified to form the Earth as we know it today. Meanwhile, molten ejected debris from that impact was thrown high into orbit, gradually accreting to form the moon. Now, a report in the journal Nature is providing a snapshot of the Moon's tumultuous past, one which could help explain long-standing puzzles, such as why the Moon's crater-riddled far side is so dramatically different from its smooth near side, which provided the backdrop for the Apollo moon landings in the 1960s and 70s. Roughly 4.3 billion years ago, when the solar system was still in its infancy, a giant asteroid slammed into the far side of the Moon, blasting out an enormous crater known today as the South Pole-Aitken Basin. This massive impact feature is the largest crater on the Moon, spanning almost 2,000 kilometres north to south and over 1,600 kilometres east to west. It's thought the oblong shape of the basin is the result of a glancing blow rather than a head-on impact. By comparing the shape of the South Pole-Aitken Basin to other giant impact basins across the solar system, the authors found that these features tend to get narrower in the downrange direction, forming a shape resembling a teardrop. Upending conventional wisdom that the South Pole-Aitken Basin was formed by an asteroid coming in from a southerly direction, the new analysis reveals that its shape narrows towards the south, indicating an impact coming in from the north. The study's lead author, Jeffrey Andrews Hanna from the University of Arizona, says the downrange end of the basin should be covered by a thick layer of material excavated from the lunar interior by the impact, while the uprange end should not. He says it means that the Artemis missions will be landing on the downrange rim of the basin, the best place to study the largest and oldest impact basin on the Moon, where most of the ejecta, material from deep within the lunar interior, should be piled up. It means the location will provide new clues about the interior structure of the Moon and its evolution through time. It had long been thought that the early Moon was melted by an energy release through its formation, creating a magma ocean covering the entire body. As the magma ocean crystallized, heavy minerals sunk to make the lunar mantle, while lighter materials floated up to make its crust. However, some elements were excluded from the solid mantle and crust and instead became concentrated in the final liquids of the magma ocean. Andrews Hanna says these leftover materials included potassium, rare earth elements, and phosphorus, collectively referred to as creep, the acronym's first letter being K, reflecting potassium's symbol in the periodic table of elements. These elements are especially abundant on the lunar near side. Andrews Hanna says if you've ever left a can of soda in the freezer, you may have noticed that the water becomes solid first. The high fructose corn syrup resists freezing until the very end and instead becomes concentrated in the last bits of liquid. He says something similar must have happened on the Moon with creep. As it cooled over many millions of years, the magma ocean gradually solidified into the crust and mantle. And eventually you get to a point where you just have a tiny bit of liquid left, sandwiched between the mantle and the crust, which is the creep-rich material. All the creep-rich material and heat-producing elements somehow became concentrated on the lunar near side, causing it to heat up and leading to the intense volcanism that formed the dark volcanic plains that make up that familiar site of the so-called face of the man on the moon. However, the reason why the creep-rich material ended up only on the near side and how that material evolved over time has long been a mystery. Also a mystery is why the moon's crust is so much thicker on its far side than its near side, the side facing the Earth. It's an asymmetry known as the lunar dichotomy, which is still posing a puzzle for scientists today. And this dichotomy affected all aspects of the moon's evolution, including the later stages of the magma ocean. Andrews Hanna and colleagues think that as the crust thickened on the lunar far side, the magma ocean below it was squeezed out on the sides, sort of like toothpaste being squeezed out of a tube, until most of it ended up on the near side. The new study revealed a striking and unexpected asymmetry around the basin which supports this hypothesis. Interestingly, the ejecta blanket on the western side is rich in radioactive thorium, but not on its eastern flank. And this suggests that the gash left by the impact created a window through the moon's skin right at the boundary, separating the crust underlain by the last remnants of the creep-enriched magma ocean from the regular crust. So, the last dregs of the lunar magma ocean ended up on the near side, where one sees the highest concentrations of radioactive elements. But at some earlier time, a thin patchy layer of magma ocean would have existed below parts of the far side of the moon, explaining the radioactive ejecta on only one side of the South Pole-Aitken impact basin. This is SpaceTime. Still to come, a new mission to study the Milky Way Galaxy's interstellar medium. And later in the science report, a new study claims the unprecedented heat waves of 2023 contributed to over 178,000 excess deaths. All that and more still to come on SpaceTime. NASA says its new Nancy Grace Roman Space Telescope will help astronomers better understand the Milky Way Galaxy's interstellar medium, that is, the dust and gas between stars. Known as the Galactic Plane Survey, the project will peer through our galaxy to its most distant edge, mapping roughly 20 billion stars, about 4 times more than have currently been mapped. Astronomers will use data from these stars to study and map the dust their light travels through, contributing to the most complete picture yet of the Milky Way structure, star formation, and the origins of our solar system. One of the mission's chief investigators, Catherine Zucker, from the Harvard and Smithsonian Center for Astrophysics, says that with Roman, astronomers will be able to turn existing artist conceptions of the Milky Way into more data-driven models, using new constraints on the three-dimensional distribution of interstellar dust. Scientists know what our galaxy looks like by comparing observations of the Milky Way with that of other spiral galaxies. The problem is clouds of dust and gas make it hard to work out details on the opposite side of our galaxy. It's a bit like trying to map your neighbourhood while looking through the windows of a house surrounded by dense fog. Roman will see through the fog of dust and gas using a specialised camera that filters observed infrared light with longer wavelengths than what our eyes can detect. Infrared light's more likely to pass through dust clouds without scattering. You see, light with shorter wavelengths, including blue light produced by stars, is more easily scattered. That means that stars shining through dust appear dimmer and redder than what they actually are. By comparing the observations with information on the source star's characteristics, astronomers can disentangle a star's distance from how much its colours have been reddened. And studying these effects also reveals clues about the dust's properties. Scientists will also learn about the dust's composition and probe clouds to investigate the physical processes behind changing dust properties. Clues in dust-influenced starlight hint at the amount of dust between us and a star. And piecing together results from many stars will allow astronomers to construct a detailed three-dimensional dust map. This would enable scientists like Zucker to create a model of the Milky Way which will show us how it looks from the outside. Then, scientists can better compare the Milky Way with other galaxies that we only observe from the outside, slotting it into a cosmological perspective of galaxy evolution. Zucker says Roman will add a whole new dimension to our understanding of galaxies because we'll see billions and billions more stars. The thing is, the interstellar medium does more than just mill around the Milky Way. It fuels star and planet formation. Dense blobs of the interstellar medium form the molecular gas and dust clouds, which can then gravitationally collapse, triggering new star formation. At the same time, young stars eject hot winds that can cause surrounding dust to clump together, forming planetary building blocks. The Roman Space Telescope will identify young clusters of stars in new distant star-forming regions, as well as contribute data on stellar nurseries previously identified by missions like NASA's now-retired Spitzer Space Telescope. Zucker says if you want to understand star formation in different environments, you need to have understood the interstellar medium that seeds it. Roman will allow astronomers to link the three-dimensional structure of the interstellar medium with the three-dimensional distribution of young stars right across the galaxy's disk. The dust maps will refine science's understanding of the Milky Way spiral structure, the pinwheel-like pattern where stars, gas and dust tend to bunch up like galactic traffic jams. By combining velocity data to dust maps, scientists will compare observations with predictions from models to help identify the causes of the spiral structure, which is currently unclear. In fact, the very role that spiral patterns play in star formation also remains uncertain. Some theories suggest that galactic congestion triggers star formation, while others contend that these traffic jams gather material but don't stimulate starbirth. The Roman Space Telescope will help solve mysteries like these by providing more data on dusty regions right across the Milky Way Galaxy. That'll enable scientists to compare numerous galactic environments and study starbirth in specific locations, like the galaxy's winding spiral arms or its central stellar bar. Roman is slated to launch no later than May 2027, with the team working towards a potential earlier launch date, possibly as soon as the middle of next year. Needless to say, we'll keep you informed. This report from NASA TV.
Astronomers around the world are working together to plan observations for NASA's upcoming Nancy Grace Roman Space Telescope. The Galactic Plane Survey, Roman's first general astrophysics program proposed by the community, promises to reveal the Milky Way in unprecedented detail. The Milky Way is our home in the universe, and there's still so much to explore. Roman pairs the high-resolution capabilities of the Hubble Space Telescope with a field of view 200 times larger, and it is able to efficiently survey the sky 1,000 times faster. The survey will capture our Milky Way galaxy across the span of its plane, and also go deeper to map the far side of the galaxy, which is largely unknown territory. Roman will help astronomers fill in missing puzzle pieces in our picture of the Milky Way, and its huge archive of data will be immediately available for any researcher to access, allowing for transformative new research for decades to come. With Roman, astronomers will get a much better census of stars for reconstructing the history of our galaxy. How did we get here? Future Roman surveys that will be developed by the astronomy community will explore additional ways to push Roman's unique capabilities to explore our biggest questions, including those we haven't yet thought to ask.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims the unprecedented heat waves that hit the world in 2023 contributed to some 178,486 excess deaths, more than half of which can be directly attributed to man-made climate change. The study, reported in the journal Innovation, used climate mortality data from around the world to estimate how many people globally have been historically dying each year as a result of heat waves, and how many deaths in 2023 were heatwave related. They found that 54.29% of all 2023 heat-related deaths were attributable to man-made climate change, with Southern, Eastern and Western Europe seeing the highest mortality rates that year. Predatory fish that evolved into the first terrestrial animals on Earth are still now revealing insights into the origins of mammals, including new research into the eating habits of lobe finfish, which inhabited an ancient reef in what is now northern Australia. The new research, reported in the journal iScience, provides fresh insights into the lives of 380 million-year-old lungfish. The research by Flinders University involved a high-tech examination of remarkably well-preserved jawbones which were found in the remote Gogo fossil field of northern Western Australia. Scientists have developed a new laser-based dating technique for measuring the age of dinosaur eggs. The findings, reported in the journal Frontiers in Earth, use carbonate uranium-lead dating to find that eggs from central China were laid in the late Cretaceous period around 85 million years ago. Until now, dating dinosaur eggs has always been difficult. Available methods are limited and prone to errors because of measurement proxies, such as volcanic rocks or crystals, which may have changed between egg-laying and dating attempts. The authors say using the new method, which involves firing lasers at eggshells, could help researchers learn more about dinosaur populations and the climate millions of years ago. Well, in case you haven't noticed it yet, the eSIM is the latest technological innovation. eSIMs are digital built-in SIM cards that eliminate the need for a physical plastic card, allowing you to activate a cell phone or tablet plan simply by downloading it onto a small chip embedded in your device. The E stands for embedded, and eSIMs offer flexibility and security, enabling you to easily switch between carriers, add multiple phone numbers to a single device, and activate plans remotely simply by scanning a QR code. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
And this is where you can get a SIM that's electronic. It's not physical. And you can now buy these. You can buy them with 20 gig of data. You can buy them with 5 or 10. You can buy them with 7 days, 2 weeks, a month, 90 days, 365 days of validity. They work depending on how much data you have and how much you've used. And if you get them with phone calls and you get them for a year's access, for example, well, you'll pay a lot for that. But you can have a SIM that just sits in your phone without interfering with your physical SIM slot. And I've been using an eSIM that gave me global access. I got it for a year with 20 gigabytes. It cost me about $87 Australian. And I've used about 14, 15 gigabytes, and I still have plenty for the trip. But this has become a very easy way of being connected and not having to worry about getting somewhere, using a physical SIM, handing over your passport, fiddling with little SIM card ejector tools. eSIM is the in thing, and I'm using an iPhone Air as we speak right now. It doesn't even have a physical SIM slot, so I have to use an eSIM. I've got one from my provider at home, but I've gotten one for global travels, and it's fantastic. You'll probably use one on your next overseas trip.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.